Today we are going to learn about interpreting machine learning models with SHAP values. We will explore how SHAP values contribute to model interpretability, enhancing transparency and trust in AI systems. By the end, you'll be equipped to implement SHAP values and interpret model outputs effectively. Welcome to our video on interpreting machine learning models using SHAP values. SHAP, standing for Shapley Additive Explanations, is a powerful method for interpreting the output of machine learning models. In this section, we'll introduce the concept of SHAP values and highlight their importance in the field of AI. SHAP values provide insights into how each feature contributes to individual predictions, making machine learning models more interpretable and transparent. This transparency is crucial, especially in sensitive applications, where understanding the decision-making process of a model is essential. Let's delve into the world of SHAP values and explore how they can help us build trust in AI systems.
Before diving into SHAP values, it's essential to set up the SHAP library in your Python environment. First, ensure you have Python installed on your system. Then, using pip, you can install the SHAP library with the command pip install SHAP. Once installed, import SHAP into your Python script using import SHAP. The SHAP library is compatible with a wide range of machine learning models, including those built with scikit-learn, XGBoost, and TensorFlow. This versatility makes it a valuable tool for any machine learning project. In this section, we'll guide you through the initial setup process, ensuring you have all the necessary tools to start working with SHAP values effectively. By the end of this block, you'll be ready to calculate SHAP values and begin interpreting your models.
With the SHAP library set up, let's calculate SHAP values for a sample machine learning model. We'll start by defining a simple model using a dataset, such as the famous iris dataset. After training the model, we'll use SHAP to calculate the contribution of each feature to the predictions. First, load your dataset and split it into training and test sets. Train a model, for example, a decision tree classifier, on the training set. Once your model is ready, initialize a SHAP explainer, which will help compute SHAP values for your test data. SHAP values measure the contribution of each feature to the model's prediction for a given instance. By following this process, you'll gain a clear understanding of how each feature impacts the model's decision-making process. This hands-on approach will solidify your understanding of SHAP values and their application in interpreting machine learning models.
Visualizing SHAP values is crucial for understanding the impact of each feature on individual predictions. SHAP offers several plots, such as summary plots, force plots, and dependence plots, each providing unique insights into model behavior. We'll focus on the force plot, which illustrates how each feature affects a single prediction. This plot is particularly useful for explaining model predictions to non-technical stakeholders, as it visually represents positive and negative contributions of features. By using SHAP's visualization tools, you can demystify complex model outputs, making them more accessible and understandable. In this section, we'll guide you through creating and interpreting these plots, enhancing your ability to communicate model insights effectively.
While SHAP values provide insights into individual predictions, understanding global feature importance is equally important. Global feature importance helps identify which features consistently influence model predictions across the entire dataset. SHAP summary plots aggregate SHAP values, offering a comprehensive view of feature impact. These plots display feature importance in descending order, highlighting the most influential features. By examining global feature importance, you can make informed decisions about feature selection, model tuning, and data collection strategies. This understanding supports model development and optimization, ensuring your models are both accurate and interpretable. In this block, we'll explore how to create and interpret SHAP summary plots, providing you with the tools to assess global feature importance effectively.
Understanding the difference between local and global interpretability is crucial for effective model analysis. Local interpretability focuses on individual predictions, examining how specific features contribute to a single instance's outcome. In contrast, global interpretability considers the overall behavior of the model across the dataset, identifying which features have the most significant impact on predictions. Both approaches have their use cases. Local interpretability is ideal for explaining decisions in critical scenarios, while global interpretability informs model optimization and feature selection. Balancing these interpretability needs is key to developing transparent AI systems. In this section, we'll delve into the nuances of local versus global interpretability, equipping you with the knowledge to apply both methods in your project successfully.
Interpreting machine learning models with SHAP values requires careful handling of both categorical and numerical features. Categorical features, such as gender or color, need to be encoded into numerical representations before being fed into the model. Common encoding methods include one-hot encoding and label encoding. Proper pre-processing ensures accurate SHAP value calculations, allowing for meaningful interpretations. Numerical features, on the other hand, may require scaling or normalization to ensure they contribute appropriately to the model's predictions. By understanding how to handle different feature types, you can enhance the effectiveness of SHAP values in your analyses. This block will guide you through pre-processing steps and feature engineering considerations, ensuring you're equipped to interpret models accurately, regardless of the data types involved. Implementing SHAP values in real-world projects requires adherence to best practices to maximize their effectiveness. First, integrate SHAP analyses into your model development workflow from the start, ensuring transparency and interpretability at every stage. Communicate insights effectively to both technical and non-technical stakeholders, using visualizations and clear explanations to convey the impact of features on model predictions. Be aware of common pitfalls, such as misinterpreting SHAP values or neglecting to consider the context of feature importance. Continuous learning and adaptation are essential, as the field of AI interpretability evolves rapidly. By following these best practices, you can build robust, trustworthy models that provide valuable insights and meet the demands of modern AI applications. This section will equip you with the knowledge to apply SHAP values effectively in your projects, enhancing both the interpretability and impact of your machine learning models.
As we conclude our video on interpreting machine learning models with SHAP values, let's recap the key benefits these values offer. SHAP values play a crucial role in enhancing model interpretability, providing insights into feature importance and decision-making processes. They contribute significantly to the transparency and trustworthiness of AI systems, enabling stakeholders to understand and trust model predictions. By implementing SHAP values in your projects, you can ensure that your models are both effective and explainable, meeting the growing demand for transparent AI. As the field of AI interpretability continues to evolve, SHAP values will remain a foundational tool, supporting the development of fair, accountable, and trustworthy AI systems. Thank you for joining us on this journey to explore the world of SHAP values and their impact on model interpretability.